I have one final example. It looks pretty massive compared to the other ones, but that's okay because we know that we have a chain rule. So how would we go about doing this? Well, if we go ahead and apply the chain rule here directly, we're going to get a 2x term in here and also a 2x term in here. Well, it will cancel out this x, but what about this expression over here? Well, we could try to split into two integrals. So we could try 2x e to the x squared minus x dx minus e to the x squared minus x dx. Well, this one's taken care of, sure, but for this expression, we're kind of in trouble because there's nothing we can substitute and cancel out, so we'll be left with an x term, and then we can't take the integral. So we have to do it another way. Well, let's try to combine them together. So this version is not good. This method is not good. So let's try to think about how we can go about doing this. Well, let's notice that there's an x squared minus x term. So on the AP exam, when they ask you a question, take really close notice to how they're asking you and what the expressions look like. So there's an x squared minus x term. Well, the derivative of x squared minus x, let's just go ahead and do that. U equals x squared minus x. Derivative of that equals 2x minus 1 dx, and dx becomes 1 over 2x minus 1 du. Well, there's a 2x here. Well, there happens to be a 2x here. What's the other coefficient? It's just 1. So we have a 2x minus 1. So if we multiply that out, and we have 2x minus 1, and we have e to the x squared minus x dx. So now we've combined these two separate subtracted portions of the integral into one portion. Normally we wouldn't do that, but for this case, it is essential that we do that. So let's go ahead and try to substitute our u in, e to the u times 1 over 2x minus 1 du. Well, these two terms cancel out, leaving us with e to the u du, which we know is e to the u plus c. And if we substitute everything back in, e to the x squared minus x plus c. So a seemingly impossible problem, once we just manipulate it algebraically, we reduce it down to something that we can handle. Then we can just apply chain rule directly once to get the answer. So solving integrals is all about being clever and seeing how they're asking you the problem and choosing the right u substitution expression. So thanks for watching Educator.com. We will see you in the next